Okay, guys, 7.5. Parts of the periodic table or sections of the periodic table. Um, it would be handy to say groups of the periodic table because in some cases we're actually talking about groups. Remember groups and periods. But some of these aren't specifically groups. They're not necessarily the same thing. They're not synonymous with groups. So let's just start with the questions here. Question 1 says, what elements conduct heat and electricity well? What elements conduct heat and electricity well? Well, I just decided I don't want to do this with just questions. I want to do the lecture. Um, First of all, the periodic table is divided into parts. Elements within one of these parts have some of the same basic chemical and physical properties. So if elements are near each other on the periodic table, they act similar. The two largest divisions of the periodic table are the metals and the nonmetals. Metals, you guys know what metals are. They're usually hard, shiny, at least until they start to oxidize. They conduct heat well, they conduct electricity well. They're flexible, you can bend them, and they're fusible. They're actually pretty easy to melt. They have low melting temperatures. Metals make up about 3/4 of all the elements. So if I have a random element in a box and I say, what is this probably? Chances are it's a metal. Now there are different kinds of metals. These include, the ones listed here. But most elements are metals. We can see everything on this side, this left 2/3 or the left chunk of the periodic table, these are metals. It's only this stuff over here on this side that's a non-metal. Within the metals, the first group we have, the first chunk, but in this case it's actually also a group, is the alkali metals. It's the most reactive of all the metals. These include lithium, sodium, potassium, rubidium, cesium, and francium. They aren't found in their pure form in nature. You'll never find lithium just by itself out in nature because it really likes to attach itself to other atoms. It likes to attach itself to other atoms because it has this one electron in its outer shell. It really likes to give up that electron. And when it gives up that electron, it becomes magnetic. It'll actually stick to other atoms that way. We'll get into that in the next unit when we start to talk about chemical bonds and chemical changes. But that's what we need to know. Alkali metals, you won't find them pure because they got the one electron in their outer shell and they hook up with other atoms a lot. That's kind of what they do. You guys have heard of sodium, but you've never seen sodium without chlorine. Sodium chloride is what you know because sodium hooks up to chlorine very, very easily, very readily. Now, the next group, the next chunk of the periodic table, it's actually also a group because it has the same number of electrons in their outer shell. These are the alkaline earth metals. As Mr. Wayne likes to say, alkali, alkaline, alkali, alkaline. The alkaline earth metals, they're kind of like alkali metals, but they have 2 electrons in their outer shell. And so they are a little different. They're a little bit less likely to react with other elements. Sometimes you will find these in their pure form in nature. Now, the metals you guys know, these are the transition metals from scandium to zinc down to copernicium, hard to say, and then ruthenium. This actually also includes technically the lanthanides and the actinides. We're not gonna harp on those for a whole bunch, but these are the metals you know. So if you're talking about valuable metals like platinum, gold, silver, these are transition metals. but it also includes metals like mercury, zinc, titanium, iron. Okay, these are the metals you know. I mean, you can read them here, right? Titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc. I've heard of all of those. Now, there is this chunk of elements. They are not necessarily metals. They don't have the same properties as metals, but sometimes they kind of do, and sometimes they kind of don't. They have a varying number of electrons in their outer shell. You can see that they sort of step to the right, so they have even more. But basically, these are elements that they act like metals sometimes, and they act like non-metals other times. We call this the stair step, but it's more appropriately called the metalloids. Metalloid means metal-like. And these are the boundary, the very blurry boundary between metals, which make up most elements, and the non-metals, which are more rare. Or less elements are non-metals. Finally, we have the non-metal, the other part of the periodic table, the other big part. This includes the noble gases, halogens, and the other non-metals. So we look at the periodic table, the noble gases, the halogens, and the other non-metals. So we started out, we were going from left to right. And once we got to the metalloids, now we're going to work from right to left, back over this way. Most nonmetals can form compounds with other elements, usually with metals, but sometimes with other nonmetals, and we'll talk about that in the next unit about chemical bonds. Nonmetals include things like carbon and sulfur and neon. This is neon in its in its plasma state. It's a gas that's been having electrons shot into it, so it's a plasma. The first group of nonmetals that we'll talk about are the noble gases. Noble gases do not attach to other atoms. If you have a helium atom, it is not hooked up with other atoms. They do not form chemical bonds. Or at least it's very, very difficult to get them to form a chemical bond. The reason for this is their outer electron shell is full. Remember when we talked about groups and periods, and we said that as you count to the right, on this edge, the outer electron shell is full. Helium has a full outer electron shell. Neon has a full outer electron shell. Argon, krypton, xenon, radon, and oganesson, they're all full. They're not going to attach themselves to lithium or sodium or potassium or rubidium. They're not going to attach themselves to chlorine or fluorine or sulfur. They just won't do it. Noble gases are the gases that are often used to fill things up. Like you might use helium to fill something up because it's not going to rust the inside of the container. It's not going to react with the container. It's safe enough to be around. If you breathe in some neon, it's probably not going to hurt you because it won't make chemical bonds with anything inside your body. It just comes right back out. Halogens. Halogens are my favorite group of elements. They are highly reactive. Just like alkali metals, they really tend to want to attach themselves to other elements. And it just so happens that the halogens are very, very attracted to other elements because they're missing just one electron in their outer shell. They have 7 electrons in their outer shell. It makes them really want to gobble up and attach themselves to atoms that have 1 electron in their outer shell. We'll talk about this when we talk about chemical bonds, but they really try to reach the point where they have a full outer electron shell. Lithium really likes to give up an electron. The fluorine really likes to take an extra electron. And so a lot of times you'll see lithium and fluorine, they're attached together. Those two totally different kinds of atoms separate atoms, they will attach themselves to each other in order to make, well, a salt. And that's where halogen gets its name, salt making. Sodium chloride is a salt. Lithium fluoride is a salt. Fluorine is the halogen, the salt-making chemical. Chlorine is a halogen. So one way to think of it is these are very, very lonely girls on the periodic table, right? The alkali metals. They're very lonely girls who are really trying to form a bond. Okay, and these are very lonely boys on the periodic table who are really trying to form a bond. Okay, they will attach themselves to one another. You won't find chlorine just out on its own, pure chlorine. You're not likely to find it. You probably also won't find sodium just out on its own. They will form bonds. We'll talk about this a lot more when we start talking about ionic bonds, but yeah, halogens. There are another group of elements that have lots of totally different properties. Carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, and hydrogen. They are all other non-metals. They're not metals, and it's hard to say anything about them all that's universally true. One thing we do know about these elements is sometimes they like to attach to their neighbors. Okay, carbon and oxygen, we know, they sometimes will form a bond. And this is a totally different kind of bond than the one we talked about between halogens and alkali metals. So there are other non-metals. These are elements that we've talked about a lot: carbon, nitrogen, oxygen. You'll hear me talk about carbon, nitrogen, and oxygen way, way more often than many of the other elements. Finally, at the bottom of the periodic table, down here, we have what are known as the rare earth metals. Two series of elements called the lanthanides and the actinides. We won't talk a lot about them. We will say that lanthanides, they all have similar chemical properties because they have the same electron on their outer shell. Even as they count across here, because of something called infilling, they all have the same number of electrons in their outer shell. I believe lanthanides all have 3 electrons in their outer shell, and so they will all attach together with the same element that's looking for 3 electrons. And it makes it really hard to separate lanthanides from each other. They're called rare earth metals. They're actually not all that rare. It's just rare to get them by themselves. You need advanced chemical processes to get lanthanum apart from whatever this next one is. Cerium. Lanthanum and cerium, it's hard to get them apart because the only thing that separates them is the number of protons in their nucleus. Their electron situation is way, way too similar to tell them apart. Again, I'm really getting into this way more than I meant to. Actinides also do the same thing, but they also all happen to be very radioactive. Their nucleuses, their nuclei, don't like to stay together, so they fall apart. This is where you get uranium and plutonium and things like that. Einsteinium, mendelevium. Okay. Okay, now to our self-check. This is where we started, and it's where we ended up. What elements conduct heat and electricity well? Well, I have a link here. Those are the metals. Okay, metals. Sorry, I linked to the wrong slide. They conduct heat well, they conduct electricity well. Those are metals. What chunk of the periodic table does beryllium belong to? And so this is just kind of a go find it question. On the test, we'll see more go find it questions. I'll ask you what kind of element is carbon, and you're going to need to be able to tell me it is an other non-metal. But here beryllium it's in group 2. It's in chunk number 2, the alkaline earth metals. I told you that specifically right here. How many electrons are in the outer shell of alkali metals? This is the most important thing to know about alkali metals is they've got 1 electron in their outer shell. The next group has 2. We skipped the transition metals because of infilling and other things we won't really get talking about. But when we get to boron, these all have 3 electrons in their outer shell. Carbon in its group has 4, and then 5, and then 6, and then 7, and then 8. And it's full. When it's full, it doesn't hook up. What is a transition metal? They're the most commonly found metals because when it comes to metals, these are the ones that are least likely or most likely to be pure. A lot of times when you find iron, it is attached to some oxygen. It will oxidize. That's rust. But you also can find iron in its pure form. You can find iron underground that is not chemically combined with another atom. And that's what transition metals are. They're metals that are often found in their pure form in nature. That's why they're the metals you know. You've never held a chunk of pure lithium because, well, it's highly reactive and it would probably explode with the moisture in your hand. But you might have held a hunk of iron before. What elements separate the metals from the nonmetals? What's the separator? That's this stair step. Okay, it's the stair step, also known as the metalloids. True or false? Nonmetals are malleable at room temperature. You can squeeze and squish a nonmetal. Nope. These are brittle at room temperature. You can't squeeze sulfur. If you try to squeeze sulfur, let me find some sulfur here. If you try to squeeze sulfur, it'll crumble like a cracker. And that's usually if you find a solid nonmetal, it's probably crumbly. It's usually not going to be solid though. Nonmetals are usually a gas. So that is false. They are not malleable. Why don't noble gases react with other elements? They're not interested, okay? They have 8 electrons in their outer shell, except for helium, it has 2, but that's full. So where lithium and all of her buddies, they're very single girls looking for boys. And fluorine and all his buddies, they're very single boys. They're looking for girls, right? Looking to form chemical bonds. The noble gases just are not interested. They are fulfilled completely by themselves. They have all the electrons in their outer shell that they want. What do halogens combine with to make salts? They combine with metals. So chlorine, it will totally combine with any of the metals. Iron, cobalt, maybe not gold. That's a whole other thing. But they especially like to hook up with the very available metals, lithium, sodium, potassium. So it is metals is the answer to that question. Where are the other nonmetals found? They are found above the stair step. Okay, they're mostly found above the stair step, above the boron, silicon, arsenic, tellurium stair step here. So it includes these in blue. Hydrogen is also a other nonmetal though. And what part of the periodic table does carbon belong to? Carbon is an other nonmetal. An other nonmetal. And if we look at the P table that we use, the periodic table online, this is actually a photo of it. You can see it actually will give you all this information about other nonmetals, noble gases, metalloids, and things like that. It'll give you those hints. But the idea that the periodic table is arranged the way that it is because of the number of electrons in the outer shell of each of the atoms is one of the most beautiful things in chemistry and one of the most important things in science. The most important things we know about the nature of our world. Okay, so that is it for parts of the periodic table. or sections or chunks, groups of the periodic table, even though they're not all exactly the same thing as a group. Other nonmetals is not a group. Okay, so that's it for the parts of the periodic table. Hopefully some of that made some sense, and we will be able to do chemical bonds with what we've learned.